Drugs are a lot like the people in the party. Some walk straight through the door, and some get stopped by the security. Today, we are decoding the body's security system, the biological membrane, and how drugs try to cross it. Pharmacokinetics is simply the journey of a drug, how it enters the body, moves through it, and leaves. And here is the key idea. The effect of a drug depends on how much of it reaches its target site unchanged. But before any drug can act, it has to cross a barrier. Biological membrane, the gate. Every cell in your body has the gate. And the gate is made of fat and protein. It's called lipid membrane. So naturally, the rule is simple. If you're lipid friendly, you can pass. If you're not, you're stuck outside. So the membrane is just not a wall. It's a very selective bouncer. And there are three ways. First one, if you have the invitation, you can get in. The passive diffusion, the main entry method. The easiest way the drugs can enter is by passive diffusion. No energy, no help. Drugs simply move from where there is more to where there is less, like people leaving a crowded room. And the most drugs use this method. But here where things get a little interesting, the pH. Most drugs are weak electrolytes, which means they can exist in two forms. Unionized, neutral, lipid friendly, ready to cross. Ionized, charged, water friendly, cannot cross. And the golden rule is only the unionized form can cross the membrane. Now, the drug is also have the preference. Weak acids like aspirin or phenobarbital, weak bases like atropine or chloroquine. Here, the simple rule. Acid stays unionized in acidic environments, but bases stay unionized in basic environments. So let's apply this. Take aspirin, a weak acid. In the stomach, which is acidic, it stays unionized, so it gets absorbed easily. Now the atropine, a weak base, in the stomach it becomes ionized, so it cannot cross. That's why it waits until it reaches in the intestine, where the environment is much more basic, and then it gets absorbed. Think the membrane is like a wall. If the drug is neutral, it passes through. If the drug is charged, it hits the wall and stops. So aspirin crosses the wall in the stomach, atropine gets blocked in the stomach. Now, imagine this. Aspirin crosses into a gastric cell because it was unionized in the stomach. But inside the cell, the pH is higher, so it becomes ionized. Now, it cannot come back out. It's like entering a room and suddenly the exit doors disappears. This is called ion trapping. And this is one reason why aspirin can damage gastric cells. Now the clinical trick, excretion. Why we can actually use this concept in the medicine. Take aspirin overdose, a weak acid. If we make the urine alkaline, the drug becomes ionized and gets trapped in the urine. So it is excreted faster. Similarly, for a weak base like atropine, we make the urine acidic, they excrete it faster. So by changing the pH, we can control drug elimination. And of course, there are some rebels who are exceptions, like ethanol, diethyl ether. They don't care about pH. They are always lipid soluble, so they cross freely. So remember, one simple rule. Unionized drugs can cross the membrane. Ionized drugs get stuck. And the biological membrane, it only opens the door to the right form. That's all for the day, people. Thank you for listening.